Hello everyone. The title and I have been already introduced. So I want to first lay some groundwork on what is telehealth in our definition here and what is AI. So telehealth here is not just visiting your doctor from home. It's not your typical telemedicine visit. It's much more than that. We are talking about remote delivery of interventions. It could be lifestyle or behavioral or other forms of intervention into people's homes. Why does telehealth matter? It should be already obvious, but still the number one is the reach. You can reach underserved communities, rural populations, and so on. The convenience, especially for people with disabilities. When it is home-based, a number of barriers automatically go away. And finally, accessibility. In-person intervention comes along with a whole set of barriers. Not that online or telehealth interventions do not have barriers, but they have consistently shown to take away many barriers. So AI, what is it? It's everywhere, in any single newspaper, TV, wherever you go, AI. What is it? So AI is nothing but if the machine can mimic human thinking. So take your old, Excel or Word. You type, you see it there. At best, you can do like a math calculation. But then beyond that, it cannot think for you. So that is not AI. But anything these days you use, you are starting to type a sentence, it's already completing it for you. That is AI. And from where do all of these happen? It all comes from data. So there is some data which has been analyzed, and that data is then used to make decisions. AI is not new. AI has been around for a long time, 50, 60 years. It used to be traditionally hard-coded, manually coded during programming. We will say, if this thing happened, then tell back to the user this. So that used to be the age-old method of AI. But in the past decade or two, we started going with machine learning. And so what is machine learning? And so you can go to a baby, show it 10 oranges, 10 apples, and then you show it the 21st fruit. It can tell you whether it's an orange or apple. It looks at the shape, it looks at the color. So that is where machine learning comes into. And machine learning field has also continuously progressed. The first big progression was what is called as neural networks. So neural networks is where the computer program tries to behave like the human brain. It's not just the apple and orange which are just different by shape. There are many characteristics. And so as a human, you see whether is it a fruit, then only you go on to this. If it was not even a fruit, you would be thinking about a tennis ball. So the multiple layers of neurons that work in your head are similar computer programming approach as neural networks. And then came what is known as deep learning. Several hundreds or even thousands of layers of neurons are laid into programming, and that's where neural networks. And parallelly, a big technological innovation was natural language processing. You can give any piece of text, and the computer being able to process it, use the grammatical rules and understand what that piece of text is telling. Finally, over the last 3 to 4 years, both deep learning and natural language processing merged together to bring about what's called as large language models. So today, if you're seeing, every day they say the stock market went up due to AI, they are basically referring to large language models. What is that big innovation there? Using the earlier technologies I spoke, we are now able to take entire printed content, any photograph existing in the world, any video existing in the world, and they have all been stored into massive computers. And the patterns within them have been studied using deep learning and natural language processing. That is when you go to your chat GPT and ask a question, it's able to figure out in that huge database, where do I go, what answer do I pick, what is the next word. They all come from these algorithms. And the next level after the large language models is what is known as diffusion language models. This is where AI is able to generate videos. I'm sure you all would have watched many AI generated videos in the past few days. So why do we need AI for telehealth? First thing is personalization. To personalize content, personalize your therapy regime is something very important, and AI makes personalization very easy. Some examples are like, you can offer tailored coaching without using a human being. You can offer tailored monitoring, not for everyone. All forms of training, monitoring is required. There again, you can personalize. Scalability. So why are we really using telehealth? Because we cannot offer services to everyone in person. So when we are thinking about telehealth, scalability is a very important thing there. Similarly, accessibility. A content expert could be generating textual content, but that textual content is not going to be accessible to everyone. So how do we make that content accessible to people with various levels of cognitive capabilities or other sensory disabilities? AI becomes a very vital tool there. That said, my presentation is just 12 minutes. I cannot go into extreme depth, but I will show you how we use AI across, I think, 6 of our different projects. So the first project I'm talking about is a accessible diabetes management project for people with disabilities and obviously diabetes. There we use what is known as natural language understanding. So a person uses an Alexa and they talk to it telling, Alexa, I had a cup of coffee and a bagel for my breakfast. All of that information automatically gets logged on to our servers, and then we are able to offer appropriate recommendations. In the subsequent meal, when they want to choose something to cook for lunch, we are able to say, hey, you already had enough carbs in the morning, let's go on a low carb lunch today. In another project, it's called the My Health, My Life, My Way. It's a chronic disease management program for people with mobility impairments. We use data and personal preferences to automate goal setting. Goal setting is a very important thing in behavioral modifications. So we use the data and personal preferences to choose actionable goals for the individuals. To be more specific, we let people choose 3 goals for the week, and then every day we send them a text message to track down on the progress in that specific goal. End of the week, we provide feedback on how well they did and where they could do better. Participants also do a self-reflective thinking on that, and subsequently the goals get revised over the journey of the program. This is an exercise study. We use a smart design like Alex just explained. Here we are increasing the physical activity levels for people with all mobility limitations. Here what we do is we offer health coaching for our participants. But then health coaching is expensive. I think that particular study has about 350 participants. To offer weekly health coaching for all 350 participants is going to be expensive. So we predict whether this particular participant is going to continue in the study next week or not. And once we detect that, okay, this participant has the potential to drop out from the study, we then intervene. We immediately send them a text telling, hey, we would like to talk to you, and it's more preemptive. But at the same time, saving significant amount of cost and enabling us to have more participants than the staffing we would be able to handle with. This is a diabetes management project, not specifically in people with disabilities, but in a rural context. Here, as I told that it's in the rural context, there is no app, nothing. All that you need is a plain old telephone. You know, the rotary phone, you can still use it if you have. So you pick up the phone, you get a call every day, or you can call into a number, and then the entire conversation happens over the phone. You talk to the phone about how your diabetes management behavior went. All that information is logged and analyzed, and every Monday you get an automated health coaching call from our systems. And so our system calls the participant and says, hey, last week we saw that you took too much of soda. So this week let's reduce your soda. Instead of a large soda you have been taking, how about pushing it down to a medium-sized soda? So here again, we learn about the participants' behavior over the week using natural language understanding, and then in the next week we deliver actionable insights. This last project is not exactly a telehealth project, but just one project to demonstrate how we are using large language models. We are trying to study the systematic exclusion of people with disabilities from clinical trials. Take any university or research center, there are thousands of projects happening. Can people with disabilities participate in all those projects? The answer is a definite no. But then how prevalent is it? So we are downloading the entire clinical trials database, and we are analyzing record by record using large language models to find whether a person with disability can participate in it. Is it justified? And how do we create an intervention to address this big systematic exclusion? All right. So we spoke much about what is already in use. Now let's talk about what is in use beyond the research context, what is in the industry out there. There are already existing virtual health assistants with personality. Let's say someone likes a humorous health coach, and then someone likes a character in the movie. There are now health coaches available with that same personalities. AI bots are now very equipped in triaging and symptom checking. I'm sure at least half of this room would have gone to ChatGPT with your symptoms and asking it, what do I have? Wearables integration. I'm sure many of you are wearing smartwatches. I can just stick my finger here and the watch is able to tell whether my ECG is looking normal or not. So more and more wearables integration and intelligent escalation to providers. There are many providers like Livongo, Teladoc and so on. They have telemonitoring devices in your homes, and anytime they notice a problem, they directly notify your provider telling, hey, something doesn't look right. So where is the future? These are some of those futuristic technologies that excite me. There is something called a digital twin used across multiple industries. It's used to mimic physical objects, systems, processes, something that is very complex. And digital twins are slowly making their way into, for humans, healthcare. So let's take an example of a particular disability, multiple sclerosis. There's already a body of literature out there over the past 2 to 3 years, which clearly talks about how do we implement a digital twin for multiple sclerosis. What are we talking about? What information do we want about the person from a genetic level? What information do we want from the environmental level? What information we want about their secondary conditions? And all of this is put into a virtual system, and now you can go change one parameter to see how everything else is going to change. Let's say, this person just wants to move from one home to another, and the accessibility is low, so their mobility is going to go low. What is going to be the impact? That impact can be analyzed so easily. Smart home integration. Just a couple of hours ago, I was dealing with a participant situation where our health coaches were not sure what happened to the participant and they were living alone. I immediately told my staff to go check their Fitbit data, see if the Fitbit steps are coming through. If Fitbit steps are coming through, the person is doing well, you are just not able to reach them. So, right now I had to do that, but going forward, all of that is going to become automatic. Finally, multi-model summaries. Right now, for much of your questions to large language models, you get a bunch of text. But the near future is where you will get explanatory videos. You don't even need to sit and read the text. You will get automatic videos generated for whatever questions you have. These three technologies are what excite me for the future interventions we would be building. But it doesn't come with certain caveats. Number one is privacy. How much data do you provide to the AI engines or chatbots? I know majority of you are from UAB here. UAB has privacy protecting AI tools. You just have to request and you will get access to it. Don't use general public AI systems and leak PHI. Next is ethics and trust. And the final thing is regulations. You need to be aware of what regulations are out there. I'll skip a few points here, but one thing I want to talk about is designing inclusively. Most of the AI systems out there are not designed in an inclusive way. What it means is the systems have been trained with data where people with disabilities are not adequately represented. And so there is a huge bias in the systems to which you talk. So it is very important that, if you are not a technology person, work with people who can fine-tune AI models for you. And so you can train the AI model to say, hey, I am going to work with people with disabilities. How should this system be changed, which is very important. Without doing those changes, if you use some of the most commercial systems, you are going to get very biased results. And AI is evolving by the day. I'm sure today evening when I go and check our newsletter, there'll be a new product out there. So keep learning. Thank you.